Okay, let's get to the next question. So the next question is question number 4. Okay, so this question is asking, if Earth were twice as far from the Sun, so let's say initially we had the Earth over here and the Sun. This distance is obviously not proportional. Let's say we have some islands and this is the Earth. Okay. So if the Earth was twice as far from the Sun, the force of gravity attracting Earth to the Sun would be. So we're trying to think about, we have some distance r, okay, and we have the force of gravity between these two objects. So the Earth and the Sun, and we have the distance r between them. So let's look at what the attempted solution by the junior tutor, and we'll look at how to come about the correct answer. So as we know, the force of gravity between two masses is directly proportional to the product of the masses and inversely proportional to the square of the distance between their centers. So this is just the equation for the force of gravity between two objects, or the attractive force, where g is just the gravitational constant and m is just the mass, the first mass, the second mass, and then divided by r squared, the distance between them. And this is kind of the explanation of the variables. Now if this distance was twice, then the force would be 2 times r, and we end up with 4 in the bottom, and we know that the force is a quarter times because of the double distance. So let's think about this. So we have the equation Fg is g times ms me divided by r squared. So the main thing to note here is we have the squared on the r, which is the distance between them. So if we were to double the distance, so we have 2r, the distance between the Sun and the Earth, now we need to kind of just substitute that in. So if we were to substitute this in, we would get, so everything on top would stay the same. And then we put this in brackets, so we have 2r squared. So knowing this, let's erase a little bit of the board here. Make some space. So we have Fg, and then this would get us Fg is equal to g ms me over 4r squared. So you can see we're left with the same equation, but we have this 4 number in the denominator. So we have the 4 here. Okay. So knowing this, we have to relate how this impacts Fg on this side. So initially we didn't have the 4 in the bottom, but now after doubling the distance we end up with a 4 in the denominator. So we know if we divided the original equation, so just kind of this, the original equation is this component, and we divided that by 4. So if we did g ms me over r squared, which is just Fg, the original force of gravity, divide that by 4, we'd end up with the 4 over here. So we know that Fg will be a quarter of what it originally was when we doubled the distance. So that's kind of how to think about how to get that answer. So I'll write it on the right side over here. So Fg would be a quarter. When we double the speed. And this is mainly because, not double the speed, sorry, double the distance. So the main reason here also is because Fg is inversely proportional. So you could say that Fg is inversely proportional to 1 over r squared. And we have the r squared component, which gives us the 2 squared, which gives us 4 in the denominator. So we can mark this answer as correct. So alright, so great job, correct answer. and we'll mark this as correct.